Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 1, Probability, brought to you by Vitan Sir. Now, before I start with my regulations, I need to give you guys two important rules which you need to remember and follow them for solving the sums of the concept of addition or even in the future concepts. The first one, when the word or is used in the question, consider it a union of events, or you can use it as addition of the two events. So when the word or is used, consider it that the question depicts a union of events or the question depicts an addition of the two events in case they are mutually exclusive. Second is when the word and is used. When the word and is used, consider it an intersection of events, or you can consider it as a multiplication of two independent events. So once again I will clarify it. When the word or is used, consider it a union of events. They will be added. In other case, when the word and is used, consider it an intersection of events, and at that time we will be multiplying the probabilities of those two events. Now how they are used I will explain in my following questions. I will be highlighting these words or and when they are given in the question, or when I am using these words in the answer with the same yellow color, so you will notice them right away when I will use them. Now starting my tutorial with exercise 1.3. Of course, I am not going to end the whole exercise in this tutorial. I am going to complete 1 to 6 sums of the given exercise in this particular video, and the remaining sums I will cover in the next. Starting with the very first question. Two cards are drawn from a pack of 52 cards. Find the probability that both the cards are drawn. But before that, because two cards are drawn from a pack of 52 cards, we need to calculate the total outcomes. Of course, there are sub questions given, but before I start with the question, I need to calculate the total outcomes. Two cards out of 52 cards will make it 52C2. That is 52 into 51 divided by 2 into 1. The answer is 1326. Okay, I think you guys got that properly. Okay, so 52C2 is 52 into 51 divided by 2 into 1. The answer is 1326. Now, moving on to the first question given. The first question is that both the cards drawn are from the same suit. Now, I hope you guys remember how these cards have been divided into 52 different cards. Okay, so when such cards are given, there are four suits which I have explained. So these both cards could be from club or diamond or heart or spades. I hope you guys have noticed the or words used with the yellow highlighted colors here. That or here means we have to add these values. So club or diamond or heart or spades. So both cards could be from club suit or diamond suits or heart suit or spade suit. How we are going to write them down is 13C2 plus 13C2 plus 13C2 plus 13C2. That will be making it 78. 4 times, the answer here will be 312. So because in each suit 13 cards are there, and we are going to select 2 cards out of the each suit, the combination here will be 13C2, and 13C2 is 13 into 12 divided by 2, that is 78. So 78 per suit will make it 4 suits, that is 312 outcomes. Those are favorable. Now total outcomes are 1326 and favorable are 312. So probability is 312 upon 1326. Simplifying it will get us 4 upon 7. You just need to multiply both the values with 78. So you will get 4 upon 17. Second question is same color. Now there are two color cards out of 52. One is red color cards, second is black color cards. So that is again red or black. Now there are 26 red cards and there are 26 black cards. So the combination will be 26C2 plus 26C2. So 26C2 is 26 into 25 upon 2, that is 325 plus 325. The total favorable outcomes are 650 and the total outcomes are 1326. The probability will be 650 upon 1326. Divide both of them with the 26 value. So the simplification will be 25 upon 51. So I think you guys must get this. Or can be union or plus. Now as you can see here, we are not calculating actual probabilities of club or diamond or heart or spades. So we can just add their combinations in each other to find the values. And basically clubs and diamonds doesn't have anything in common between them. So when there is nothing common between two values, you can just add them up. That is the result which we did in the previous tutorial. When there is nothing common, that means there is no mutual, when these events are mutually exclusive, you can just add them up to find the union. So club, diamond, heart, spades are mutually exclusive events. They don't have anything in common. So we can just add them up to find the value. Similarly, red or black are again mutually exclusive events, so we can just add them up to find the favorable outcomes. Moving on to the second question. Question number 2. 3 books of statistics and 4 books of mathematics are arranged on a shelf. 2 books are randomly selected. We have to find the probability that both books are of the same subject. First of all, we are selecting 2 books out of the total 3 plus 4, 7 books. So the total outcomes here will be n is equal to 7C2, that is 21. So the n is 21, the total outcomes. Now the question here is both the books should be of the same subject. That means both should be from the statistics or both must be from the mathematics. Now as you can see here, there is nothing common between statistics and mathematics. Okay, so where they are mutually exclusive events, we can just add both the events up and we will get their union values. So here we are just going to add the values once again. That means we will select 2 books from statistics, add them up with the selection of 2 books from mathematics. So that is or means adding up. So the favorable outcomes will be 3C2 plus 4C2. Now 3C2 is 3 into 2 divided by 2, that is 3. 4C2 is 4 into 3 divided by 2, that is 4 3s are 12 divided by 2, 6, and 3 plus 6 is 9. So the favorable outcomes here are 9 and total outcomes are 21. So the probability will be 9 upon 21, dividing both of them with 3 will get us 3 upon 7. So the probability that both the books are of the same subject is 3 upon 7. I hope you guys are getting the point of these things here. Or means add or union, but because these events have nothing in common, we can just add them up without considering anything else. Moving on to the third question. Now this is a question where we might have to use the full calculation of union of events, that is the law of addition. One card is randomly drawn from a pack of 52 cards. Find. But before we find, number 1, spade or S. That means the card drawn from the 52 cards is either a spade card or an S card. Okay, now here we will need some calculations. So I will start giving names to the events here. For example, spade is, I will name it event A. Of course, we know spade cards are S1, S2, dot, 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 SJ, SQ, SK. That means 13 cards are there. S1 can also be known as SA, that is spade of S or S of spades. We can call it like that also. Event B I am going to name as the S cards, that is heart S, diamond S, spades S and club S. So there are 4 cards. So number of spades cards are 13 cards and number of S cards are 4 cards. The question here is used is or, and or is considered as union of events. And if you remember the union of events, that is the previous tutorial of this. If you don't, you can just check out its link on the top right corner on the screen. So that video explained the formula for using the union, that is A union B is A plus B minus A intersection B. So A intersection B we will need to find here. Intersection means and. So event A intersection B is S and spade card. That is a card which is S as well as spades. So that will be S of spades, that is just one card. So event A has 13 cards, event B has 4 cards, and event A intersection B has 1 card. While the total outcomes here, because we are only selecting 1 card out of the 52 cards, that is 52 total outcomes. Now we have to calculate separate probabilities for A, B and A intersection B. Starting with A, 13 cards out of 52 cards, so 13 upon 52. Event B, 4 cards out of 52 cards, and event A intersection B, just 1 card out of 52 cards. Now, because we have all the 3 necessary probabilities, we can start with the union of events, that is A union B, that is A minus A plus B minus A intersection B. We are going to put the values into equation here. 13 upon 52 plus 4 upon 52 minus 1 upon 52. Now, in case you were wondering before why I did not simplify the events A and B, this was the reason. If I would have simplified them earlier, I would have to again find the LCM for all the 3 events. So it's better not to simplify them and keep their divisional values equal, so to make the calculation shorter. Because the divisional values, the denominators are equal here, I can write them like this: 13 plus 4 minus 1, and the final answer here will be 16 upon 52, but I will need to simplify this final answer because there is nothing afterwards. That will be 4 upon 13. So the probability that the one card drawn is a spade card or an S card is 4 upon 13. So this is the system of calculating union of events. You need to calculate event A, event B, and then event A intersection B, and find their probabilities, and then find the union of events A and B using probability A plus probability B minus probability A intersection B. The second sub question is neither spade nor S. Now that means it cannot be a spade card and it cannot be an S card. Okay, let's start with event A dash, that is a not a spade card. Spade card was denoted by A, not a spade card is event A dash. Similarly, event B dash, which denotes not an S card. Okay, so event B dash is where we can say it is not an S card. So where it is not a spade card and not an S card. Once again, not a spade card and not an S card, and denotes intersection. So event A dash intersection B dash denotes neither spade nor an S card. That means it is not a spade card and it is not an S card. Now, in very earlier of my videos, I explained the various forms of the probabilities. You can find it in my video number 1.3 most probably. So in that I explained the formula for this, that is probability A dash intersection B dash is probability A union B the whole dash. That will be 1 minus probability A union B. Now probability A union B we just calculated in the previous subsum. So 1 minus 4 upon 13, when we find the LCM here, it will become 13 minus 4 upon 13, and the answer will be 9 upon 13. So the event where it is neither spade nor S card, the probability of happening of that event is 9 upon 13. So the union of events was 4 upon 13 and its exact opposite is 9 upon 13. Moving on towards the question number 4. A number is selected from numbers 1 to 100. Find the probability of event that selected number is a multiple of 3 or 5. It is a multiple of 3 or 5. Again, or is used, so I suppose we will have to depict them using the union, but before that we will as usually find out the events. That is event A is a multiple of 3, So the multiple of 3's could be 3, 6, 9 up to 99. And when you calculate them, you get 33 numbers. Okay, so out of 1 to 100, the number of multiples of 3 are 33. Similarly, event B will be multiple of 5, that is 5, 10, 15, 20 up to 100, and out of 1 to 100, the multiples of 5 are 20 numbers. There are different 20 numbers which could be denoted as multiple of 5 out of 1 to 100. Because we are calculating union, we will also need to calculate intersection. That is event A intersection B, that is multiple of 3 and multiple of 5. So 3 and 5, so multiply them. Yeah, just multiply them. 3 5s are 15. So the multiples of 15, that is 15, 30, 45, 60, 75 and 90. The 6 numbers are there which are the multiples of 3 as well as 5, that is multiples of 15. That will be the event A intersection B. Now we know that numbers are from 1 to 100, so the total outcomes will be 100. The probability of A will be 33 numbers out of 100 numbers, B will be 20 numbers out of 100 numbers, and A intersection B will be 6 numbers out of 100 numbers. So once we got the probabilities of A, probability of B and probability A intersection B, just put these probabilities into the equation of A union B, that is probability of A plus B minus A intersection B. Put the values which we just calculated into this equation, that is 33 upon 100 plus 20 upon 100 minus 6 upon 100. Because the denominators I have kept same, it will be 33 plus 20 minus 6. So your answer here will be 47 upon 100, and of course we can convert this into decimals very easily as 0.47. There is not an issue if you keep them in fractions, but I just thought that if it is in the division of 100, just convert it into decimals, it looks better. So the answer for the fourth question is 0.47. Moving on with the next question here. Question number 5. Two balanced dice. Okay, so it's a question of balanced dice. You will have to draw the whole thing, of course. Are thrown simultaneously. Find the probability that sum of numbers on dice is multiple of 2 or 3. Once again, it is a question of union of events. The sum of numbers on dice is a multiple of 2 or 3, but before that it is a compulsory thing that we have to draw the two balanced dice total outcomes: 1 1 1 2 1 3 1 4 1 5 1 6, 2 1 2 2 2 3 2 4 2 5 2 6. Similarly, we have to go up to 6 6. Okay, we got to 5. 5 1 5 2 5 3 5 4 5 5 5 6, and ultimately 6 1 6 2 6 3 6 4 6 5 and 6 6. Okay, so 36 outcomes are there. Now I'm going to draw the lines here to differentiate them. The sum here is 2, okay, and the number of events here is 1. So the events with the sum 2 are 1. Similarly, you have already done this once or twice before. Events with sum 3 are 2, events with sum 4 are 3, and continuing forward, you just need to make the lines and write down the sum and the events so that your calculation becomes a lot easier, simpler and faster. Okay, so that's done. Now before I move forward to next slide, I just want to confirm some things with you guys. We have to calculate multiples of 2 or 3. So naturally our event A will be multiple of 2, event B will be multiple of 3, and event A intersection B will be 2 and 3, that is 2 3s are 6. So let's see here. Multiple of 2, that is 2, 4, 6, 8, 10 and 12. Sum 2, sum 4, sum 6 and 8, 10, 12. So sum 2 has one event, okay, keep that in mind. Sum 4 has 3 events, so 3 plus 1 4. 6 has 5 events, so 4 and 5, 9. 8 has again 5 events, so 14 events. 10 has 3 events, so 17 events, and 12 has 1 event, so 18 events. So there are 18 distinct events when the sum is a multiple of 2. Remember that? Of course, I have written that down, but just remember that. Multiple of 3 is 3, 6, 9 and 12. So 3 is 2 events, 6 is 5 events, that is 7, 9 has 4 events, that is 11, and 12 has 1 events, that is 12. So the events which are multiple of 3 are 12. And then 2 and 3, that is multiple of 6. So that is 6 and 12. So 6 has 5 events and 12 has 1 event. Multiple of 6 has 6 events. Okay, once we are clear with that, it will be easier to understand. Event A, that is sum, is multiple of 2, 18 outcomes. Event B, sum is multiple of 3, 12 outcomes. And event A intersection B, that is sum is multiple of 2 and 3, that is multiple of 6, 6 outcomes. Total outcomes, of course, we know because they are 2 dice, 36. Probability A here will be 18 outcomes upon 36 outcomes. Similarly, B will be 12 upon 36 and A intersection B will be 6 upon 36. Of course, I am not simplifying this so that it becomes easier when we are calculating the unions. A plus B minus A intersection B, putting the values in the equation here, 18 upon 36 plus 12 upon 36 plus 6 upon 36, that is 18 plus 12 minus 6. The answer here will be 24 upon 36. You can find the 12 as a common factor here, so 12 2s are 24 and 12 3s are 36. So when the event is that the sum on the faces of dice is a multiple of 2 or 3, your answer, the probability here will be 2 upon 3. Moving on to the last question of today's tutorial, the remaining question I am going to do in the remaining videos. The probability that price of potato rises, it's actually a very easy sum because in the vegetable market is during festive days, is 0.8. So probability is directly given. The probability that price of onions rise is 0.7. Okay. The probability of rise in price of both potato and onions is 0.6. Find the probability of rise in price of at least one of the two, potato and onion. What we are going to do, first of all, event A is rise in price of potato. The probability is already given, 0.8. Similarly, rise in the price of onion is event B, so probability is 0.7. And I have highlighted the words here, at least one. Now I think you guys must be familiar with at least one. This is a group of words used in the definition of law of addition itself. So when at least words are used, it means we have to use the union formula. So events A intersection B, because to calculate union we need intersection. Rise in the price of potato and onion is A intersection B, 0.6. What we are going to do next is just write down the formula for union, that is probability A union B, that is A plus B minus A intersection B, 0.8 plus 0.7 minus 0.6. The answer here is 0.9. So the probability that the rise in price of at least one of the two happens, that is potato and onion, is 0.9. So this is the end of question number 6. The remaining sums I will do in the next tutorial. Welcome students to Vitan's Unaccount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.